So far, we've managed to move the Turtlebot using the keyboard. However, we want to do more interesting stuff. I want to write one simple command and then have the robot move on its own. So let's see how we can do that. Well, first of all, we will try to find some information about the running system. Well, to do that, let's actually start the system. I'll do ROS, launch, Turtlebot, gazebo, and then Turtlebot world. So doing so, I will open up my gazebo simulation. And I see it right here. Let's zoom a little bit in on this robot. And it's pretty much standing still. Okay, well, I have already managed to move the robot using the keyboard node. So for that, let's run it again. ROS launch, Turtlebot, teleop, and keyboard. Well, now if I press E, I see the robot drive forward. But now I want to publish to the same topic this node is publishing to, but on my own. So let's find some information about this node. I'll do a ROS. Well, first of all, what is this node called? I'll do a ROS node list. And I see right here, Turtlebot teleop keyboard. So now let's find information about this node, ROS node info. Oh, Turtlebot teleop keyboard. And as I scroll up right here to the publisher and subscribers, I see it's publishing to command velocity mux input teleop. So probably if I publish to this topic, I can also make the robot move. So now let's see more information about this topic. Right now I'll press ROS, topic, info, and what was it called? Command velocity. Command velocity, mux, and then input, and teleop. Well, you see, simple topic. Its publisher is the Turtlebot teleop keyboard, and its subscriber is the mobile-based robot. But I'm now more interested in this part, the type of the message, geometry message twist. And we've already seen that before. And it's also included in our tutorial. So now let's publish to this same topic using this message. I'll do a ROS topic, pub, and then I will press the name of the topic, command velocity mux input teleop. And if I press now a tab again, I can see the basic format at which I should publish. XYZ linear and XYZ angular. Well, X linear determines how much I drive the robot forward. So let's see, if I do this 0.5 and I press enter, nothing happens. What is happening right here? I don't know. Well, let's figure out. I'll open up a new terminal, and to debug our code, it's often useful to use an RQT graph. So press ROS, run, RQT graph, RQT graph. And it opens up a very nice visualization right here to see what's happening. So I'm looking at this command velocity right here, mux, or this one right here, and I see which topics are publishing to it and which topics are subscribing, or which nodes are publishing to it. And I see the Turtlebot teleop keyboard and something else, and this topic is subscribed by to this node. So why can't I send commands using the topic right here? Well, maybe because I have two publishers to this same topic at the same time. So let's try switching off the keyboard and see what's happening. I'll press here, Control-C. Here's our keyboard node. Press Control-C, switch that off, and then switch this one off and run it again. You see right now, as I pressed, the robot just moved. Well, it moved for 1 second because I executed the command just for 1 second. Once, press again, you see the robot moving again. Forward with linear velocity. Now let's try to see what happens when I use the angular velocity. The robot seems to move a little bit and rotate a little bit. Let's try it again. But now let's let the robot move backwards by adding a minus sign. You see, the robot just rotated a little bit. If I increase this z value to 0.9 maybe, you see it's rotated a little bit more. But it's just moving in very impulses. It moves a little bit and then it stops again. How do I make the robot keep moving for a while? Well, I could use the same command, and then right here I will add minus R10. After publish, I'll add minus R. Oh, that's not good. Let me erase this. Minus R and then 10. And what does that minus R10 mean? Well, that's the rate at which I keep publishing in milliseconds. So let's move on again. Command velocity. Oops. Minus R10. And then command velocity. Input. And tally up. Something is wrong. Let's try it again right here. Minus R, 10. And as you see right here, the robot keeps moving with a linear velocity and an angular velocity. So it moves forward and rotates, and so it moves in circles. You see right here, it's colliding with some object and now doing some random movement. If I now press Ctrl C, would the robot stop moving? Let's take a close look. It seems to have stopped moving. Okay, that's it for this short tutorial. And in the next one, we will try to write a Python script to execute a more interesting movement pattern.